12.3 is all about rotations, okay? Remember, you guys, a rotation is a transformation that turns a figure around a fixed point. This point is called that center of rotation. We talked in 12.1 about an isometry. A rotation is an isometry, so the image that gets rotated will be congruent to the pre-image. For these drawings, you can just estimate by tracing the original pre-image and then rotating your paper, because I'm going to actually give you amount of degrees to rotate. Unless otherwise stated, remember all rotations will go counterclockwise, okay? Let's give it a shot. Tell me whether each of these transformation appears to be a rotation. Well, let's take a look at the first one. In this first one, if I look at my pre-image and I go to my image, does this look like it's been turned at all by any degrees? I would say no. This actually looks like it is a reflection. So this is a no, no, no. This next one, if I look at my pre-image to my image, it looks like it's been turned. So yes, this is a rotation. Can you tell me how many degrees it's rotated? If it goes from here to here, I'm guessing it's 90 degrees. Do you need this part? Not quite yet, but we'll get there. I would like for you to pause, please. Do this next one, and then, or do the next two, we'll say, and then come back and we'll go through them. All right, so this one's a no because this is just slid. If it was rotated, this would actually be upside down. And this is a yes. It was a nice clean turn over this way. All right. Here we go. A rotation is a transformation around a point. This is called the center of the rotation. Each point and its image are the same distance from P, and all the angles with the vertex are at P. So in this figure, angle A prime, is simply called the angle of rotation, and P is called your center of rotation. So let's look at this first example here. It says copy the figure and the angle of rotation, and then draw the rotation of the angle about Q by the measure of angle A. Okay? So first things first, we're going to have to measure this angle. And I'm not sure if you guys have protractors at home, but I can give you a hint. If I draw on a right angle here, and you take a look, if this is 90 degrees and we're about halfway through, I can kind of estimate that this angle is about 45 degrees. So what they're looking for is for you to rotate this image here 45 degrees around this point Q. The easiest way to do that, the easiest way is to connect this image to that dot. So what I would do is I would take a ruler or some sort of a straight edge and draw a connection between the figure and the point that you want to rotate around. From here, if you remember, we rotate counterclockwise. It needs to be rotated 45 degrees. So if you have a protractor, wonderful. If not, we're going to have to use some sort of an estimation. I'm going to say from here to here, the 45 degree angle is about there. So I would say that this is about 45 degrees. Okay? After you draw your 45 degree angle, then all you have to do is redraw your image. So if I redraw my image, it kind of looks like this. This is my drawing for a 45 degree rotation about the point Q. All right, so I hope you have your note card handy. Here's your rules. If you have a rotation in a coordinate plane, if you rotate by 90 degrees around the origin, the rule is this. You're going to take your pre-image, let's say my pre-image is 1, 2, and you're actually going to flip and take the opposite sign of y. So this would become a negative 2, 1. The reason why is because you're going 90 degrees. You're going into a different quadrant. If you rotate 180 degrees around the origin, all you're going to do is change the signs. You're going from one side to the other. So if I start at 1, 2, I'm ending up at negative 1, negative 2. Okay? If the angle of rotation in a coordinate plane is not a multiple of 90 degrees, you can just simply use the sine-cosine ratios to find the coordinates of the image. All right, so first example says they want you to rotate triangle JKL with these vertices about, sorry, by 180 degrees about the origin. Okay, so first things first, my rule, if I rotate 180 degrees about the origin, I take my pre-image, and then I have to, if it's 180 degrees about the origin, switch the signs here. Okay, so if my pre-image for J is 2, 2, K is 4, -5, -5, sorry for my handwriting here, and L is -1, 6, what happens is I go through this transformation here, and I have to switch my coordinates here. So this would end up being -2, -2, -4, +5, and 1, -6. So this would be J prime, K prime, and L prime. Just simply follow the rule. All right. I want you to please copy down this problem. We are going to go over this Ferris wheel problem in class. Make sure that you have it ready to go because this is going to be something that you're going to want to discuss.